Here we have AP calculus AB problem. Okay, let's go to the question. Find limit x approaches 0, square root of x positive 9, negative 3 over x. Okay, to evaluate the given limit over here, let me start with direct substitution. That is, I'm going to substitute the given limit of x, that is 0, for x over here. Okay, now let me write the given limit as it is. That is limit x approaches 0, square root of x positive 9, negative 3 over x. Okay, now let me directly substitute the given limit for x into the function over here. Then I'm getting square root of 0 positive 9 negative 3 over 0. So 0 positive 9 is 9. That is, we have square root of 9 negative 3 over 0. So square root of 9 is just 3. 3 negative 3 over 0. 3 negative 3 is 0. I'm getting 0 over 0. When I evaluate limit, if I get the result like this, it is 0 over 0, it's called indeterminate form. Okay, let me write the stuff over here. Indeterminate form. And when we get indeterminate form, that is 0 over 0, as a result in the evaluation of limit, we cannot consider this is a final answer, and also we cannot say the limit does not exist. So definitely this limit exists because I am getting 0 over 0, indeterminate form as a result. So what do we have to do to get the correct value for this limit? So for that, what we have to do is we have two options. One is we can use the L'Hopital's rule in the given limit. Otherwise, we can do any possible simplification if it is. Okay, I think we can simplify the function we have over here before we plug in the given limit for x. So what simplification we can do in this function? So that is, I can consider this particular part in the numerator because it contains the square root over here. I can take the conjugate of this expression numerator. I'm going to multiply both numerator and denominator by the conjugate of this expression. Let me do it in the next step. Limit x approaches 0, square root of x positive 9 negative 3 over x. I multiply both numerator and denominator by the conjugate of this one. Conjugate means I just have to change the sign in the middle. Already we have negative. So to get conjugate of this one, we have to change this negative as positive. Then I'm getting square root of x positive 9, positive 3 over square root of x positive 9, positive 3. Okay, now let me consider an algebraic identity, that is a square negative b square, which is equal to a positive b times a negative b. It's one of the basic and important identities in algebra. So on the left side, we have the difference of two squares, a square negative b square. So whenever we have difference of two squares in this form, it can be written in the factor form a positive b times a negative b. And also let's look at it in a different way. That is, we multiply two binomials, that is a positive b and a negative b. So whatever the first term is here, the same first term we have over here. Whatever second term we have here, the same second term is over here. So one binomial contains positive, the other binomial contains negative. So whenever we multiply two binomials like this, we have to square the first term and we have to square the second term. Between them, we have to take a negative sign over here. Now let's consider the product of two binomials over here. So whatever first term we have over here, the same first term is here, and the second term is also same. So one binomial contains negative, the other binomial contains positive. So these two binomials are in the form of like this a positive b, a negative b. So to get the product of this one, we have to square up the first term, square the second term. We have to take a negative sign in between them. Okay, now let me do it in the next step. That is limit x approaches 0. So like to get the product of these two binomials, let me square the first term, that is square root of x positive 9, the whole square. We have to take negative sign. We have to square the second term, that is 3 square. And we have to multiply the two denominators we have over here. Then I'm getting x times the square root of x positive 9, positive 3. Okay, now let me continue over here. Limit x approaches 0. And here the square root and square will cancel out. I'm getting x positive 9, negative. The evaluation of this 3 square is 9 divided by x times square root of x positive 9, positive 3. So this positive 9, negative 9 will cancel out because it's a 0 pair. Limit x approaches 0, x divided by x times square root of x positive 9, positive 3. And we can cancel this x over here, that is x goes into x one times, x goes into x one times. Now let me write the next step. X limit x approaches 0. We get 1 over square root of x positive 9, positive 3. Okay, that's all the simplification we can do. Now we can plug in the given limit, that is 0 for x over here. In that case, I'm getting square root of 0 positive 9, positive 3, which is equal to 1 over square root of 0 positive 9 is just square root of 9. Square root of 9 is 3, 3 positive 3, which is equal to 1 over 6. So the evaluation of the given limit is equal to 1 over 6.